Let's talk about LLM temperature and why it matters beyond just model tuning. Temperature controls how predictable or creative a model's output will be. Lower values make responses more consistent, while higher values allow more variation. For AI engineers and agent-focused roles, knowing when and how to adjust temperature shows practical judgment. It's a small parameter, but it can reveal how well someone understands reliability, experimentation, and real-world AI behavior. Here's what we'll cover. First, what temperature actually is in language models, the setting that influences how tokens get sampled. Then we'll look at how changing it affects output, especially the trade-off between consistency and creativity. After that, I'll share practical guidance on when to use different settings, including how major vendors support them. And finally, we'll connect all of this to portfolio work and interview conversations. Temperature isn't just a model setting to memorize, it's an operational control that shapes reliability, user experience, and even how you evaluate results. Across providers, the guidance is consistent. Higher temperature increases randomness and variety, while lower temperature makes outputs more focused and predictable. OpenAI recommends 0 for factual tasks. Google frames it as token selection randomness, and Anthropic calls it injected randomness, best kept near 0 for analytical work. Here's the mechanics of temperature. First, the model computes a probability distribution over possible next tokens. Then temperature is applied by scaling the logos, which makes that distribution either sharper or flatter. After that, a token is sampled from the adjusted distribution. So temperature changes how confidently the model picks among options. It doesn't add knowledge or change the model's understanding. It only affects how the next token is chosen. Temperature controls how predictable the model's next words will be. At low temperature, it sticks close to the most likely continuations. So outputs are more consistent, easier to parse, and easier to test. At high temperature, the distribution spreads out, allowing less likely tokens and creating more variety and creativity. As a rule of thumb, OpenAI around 0.2 feels focused, while 0.8 feels much more random. With Google, even 0 can still show small variation. One key point to remember is that temperature is not the same as truth. Lowering temperature reduces randomness, so the model's outputs become more consistent, but that does not make them more correct. A temperature 0 model can still hallucinate. It will just do it the same way every time. So when you evaluate models, keep consistency and correctness as separate metrics. Temperature doesn't work by itself. It interacts with other sampling controls, especially top P and top K. Top P removes the low probability tail before temperature is even applied, while top K limits the model to a fixed number of candidate tokens, and defaults matter too. For example, Hugging Face uses 1.0 unless you change it, so two systems can share the same temperature and still produce noticeably different results if their top P or top K settings differ. Here's the key rule for tuning. Change one control at a time. With OpenAI and Google Vertex AI, the guidance is to adjust either temperature or top.p, not both together, because changing multiple settings makes the model's behavior much harder to interpret. Anthropic goes even further, with some models not allowing both at once. The disciplined approach is simple. Tune one variable, keep the rest fixed, and document what changed. Use low temperature when consistency matters more than creativity. In extraction, pipelines like invoice parsing, resume field extraction, or form processing, you need stable schema output every time. The same goes for classification and triage tasks, such as ticket routing, compliance labeling, or intent detection, where consistent categories are essential. And for tool calling agents, low temperature helps ensure JSON and API outputs stay predictable, valid, and easy to parse. Use higher temperature when you want variety, not just precision. It's especially useful for brainstorming and ideation, like exploring marketing copy, campaign concepts, or tagline options where diversity matters. It also helps with synthetic data, since broader exploration can produce more varied training examples or test scenarios. And for multi-candidate drafting, you can generate several controlled options first, then compare and rank them instead of relying on one unpredictable output. Here's a quick temperature cheat sheet by task. For factual QA, retrieval and structured extraction, keep temperature very low, around 0 to 0.2. For consistency, accuracy, and reliable parsing, tool calling agents also stay low for stable JSON and API arguments. Code generation can be slightly higher. Summarization works well in the middle. For creative writing and brainstorming, raise temperature significantly to encourage more variety, originality, and exploration. A reliable pattern here is multi-candidate generation plus ranking. Instead of asking for one high-temperature output, we generate several candidates at a moderate temperature. Then we score and rank them with either a model or simple rules, filter them through schema and quality checks, and return the best result. Vertex AI supports this directly with candidate count, giving you useful diversity while still keeping the output controlled and on spec. One important nuance: setting temperature to 0 does not guarantee perfect determinism. It usually makes outputs much more consistent, but small variations can still happen. That's also how the vendors describe it. Google says results are mostly deterministic at 0 temperature, with occasional variation, and OpenAI says lower temperature makes outputs more focused and deterministic, not identical every time. So don't promise perfect reproducibility unless your specific platform explicitly guarantees it. When designing evaluations, control temperature first. For benchmark runs, keep it low so randomness doesn't muddy the results. Just as important, record every generation setting, including temperature, top tempka2, and the exact model version. Also, separate consistency from correctness. They measure different things and should be reported independently. And whenever you compare prompts or models, keep all generation parameters fixed so you're making a true apples-to-apples comparison. For your portfolio project, build a simple experiment that shows how you evaluate model performance, measure parse success, and schema adherence. Check exact match consistency across repeated runs, and use human preference scores for more creative outputs. If you can, include token cost or latency too. Then clearly write up what changed, what you learned, and why you chose the final setting. That write-up is the portfolio piece that helps get you hired. This slide shows the difference between weak and strong interview answers. Weak answers are vague, like blaming the model or assuming temperature 0 is perfectly deterministic. Strong answers are specific, testable, and tied to system behavior. They explain likely causes, suggest concrete fixes, and mention measurement, like lowering temperature for tool use, generating multiple candidates for ideation, or empirically checking reproducibility instead of relying on assumptions. What interviewers are really testing isn't just whether you know the terms. They want to see if you can choose a parameter for a real business problem, test it in a controlled way, and clearly explain what happened. They also want to know that you understand how it works alongside top TAC, and that you can back it up with a concrete portfolio example that shows your thinking. Here are a few common mistakes to avoid. First, don't treat temperature like a quality dial. Higher temperature gives you more variety, not automatically better results. Second, avoid changing temperature and top all API at the same time, because then you can't tell what caused the difference. Also, don't claim exact reproducibility, even at 0. And finally, always match the setting to the task. There's no single best temperature for everything. Here's the one slide takeaway. Temperature mastery has 5 levels, but most candidates only demonstrate levels 1 or 2. What hiring teams really look for is levels 4 and 5. Knowing how to match temperature to the task, keep parameters disciplined, and show measured evidence of the results. The key idea is simple. Temperature isn't a magic quality knob. It's a controlled trade-off between consistency and diversity. Here are the key takeaways. Use low temperature for stable, factual, structured work, like agent and tool tasks. Usually start around 0 to 0.3, and only raise it with a clear reason. Use higher temperature for creative ideation or generating multiple options, but always pair that with ranking or evaluation. Change one knob at a time. Don't tune temperature and top together. And finally, show your work. A solid experiment write-up matters more than memorizing definitions.